In this episode of Home Theater Geeks, I chat with Jason Fiber, THX CEO, and Kasson Crooker, Senior Director of Product Development, about a new THX technology called Spatial Audio. Check it out.
Podcasts you love.
From people you trust.
This is TWiT.
Hey there, Scott Wilkinson here, the Home Theater Geek. In today's episode, I'm delighted to welcome two guests, CEO of THX, Jason Fiber, and Senior Director of Product Development, Kasson Crooker. Hey guys, welcome to the show.
Thank you for having us.
Thanks for having us, Scott.
We're so happy that you're here because we're going to be talking about something really interesting, a THX technology called Spatial Audio. But before we get to that, Jason, why don't you give us just a super brief history of THX? Many people know the name, and anybody who goes to the movies has probably heard the Deep Note.
Nice impression.
And but many people may not know, exactly where THX came from and what its mission is. So give us a quick overview of that.
I'd be happy to. So THX was formed 40 years ago by a filmmaker named George Lucas, who had
him. I sort of remember him.
Encountered a little bit of success with an obscure little movie called Star Wars. Mm-hmm. As his clout grew in Hollywood and The Empire Strikes Back was released, the story, as I've been told it goes, he showed up in a movie theater that was showing The Empire Strikes Back and was horrified by how it looked and how it sounded. So as he was preparing the third movie in the trilogy, which of course we all know is The Return of the Jedi, he created a program for cinema operators to upgrade and build new cinemas to a specification that he called the THX certification program. And those operators that were willing to upgrade their rooms and or build to a higher specification were granted the right to include outside the room a plaque that said THX certified, to run a trailer featuring the classic Deep Note sound, as well as advertise it in the movie's ads and outside on the marquee. And so THX for cinema certification was born, and it was a very successful program. Obviously, a great deal of people associate THX with cinema as a result of our association with Lucasfilm. As the company grew and as the brand became more known, we moved into the domain of home theater, which was kind of the next echelon of filmed entertainment. And so we started certifying a lot of home theater equipment, the subwoofers, the speakers, the projectors, the screens, etc. Mm-hmm. And from there, the company grew into a larger brand and really provided the mark of quality across the entertainment spectrum, particularly on, like I said, home theater products, also consumer electronics, continue to maintain the cinema certification program, and more recently has grown into providing technologies for different kinds of products, including one that we're particularly proud of and are deeply invested in, which is spatial audio. So that's the brief version in a nutshell.
That's a nutshell for sure. 40 years in a minute and a half, but that's great. Thank you. And so, yes, we're here to talk about spatial audio, which I think is the latest of the THX technologies to come to market. So, Kasson, why don't you give us a brief overview of what is spatial audio?
Sure, of course. And so even before getting into THX spatial audio, to give either a refresher to your viewers or maybe for newbies who are have heard this word a lot, and they've and they've probably heard it in other ways and descriptions through immersive audio, 3D audio, virtual surround sound, 360 audio outside of your head. I mean, there's so many descriptors for this. Some of them are helpful, some of them are confusing, and not always apply directly to the end game of delivering a good spatial audio experience. But setting all the marketing buzzwords aside, spatial audio's goal is really to simulate how we hear the real world, right? Physiologically, we have heads and ears and torsos, and we're in this space. Depending on the kind of acoustic environment, we're outdoors, indoors. And then we're hearing the world around us, all around us. So we can hear things behind us and above us. And of course, we don't hear on its own, right? Our bodies are very elaborate fusion of sensors that are taking in a lot of information and then fusing that together to, build our perception of reality. So there are many times when we encounter audio in very unreal ways, right? We're all used to the beginning of recorded audio was mono. We hear essentially with 2 ears. So we hear very binaural. And so the leap from mono to stereo was important. And then since then, there have been interesting ways to expand and make that listening experience more interesting, depending on the kind of content or experience that you're in, whether you're in a theater and you want things all around you, whether you are in VR and you want things literally all around you, above and below, near and far, or you're at home just listening to stereo. So there are a number of different areas where we listen and are in different sort of environments that our bodies are normally used to. So spatial audio is attempting to recreate that experience so that if you say you have headphones on, you can still make it sound like sound is natural and all around you and not just basically inside your head in your ear cup sort of hitting you right away, which can be a very unnatural and sometimes fatiguing listening experience. And so spatial audio has been around for quite a while, especially at the academic level, going back 40 or 50 years with technologies like quadraphonic, ambisonic, et cetera. But now we're seeing a lot of interesting spatial technology really show up in mass market devices. We're hearing them in earbuds, TWS earbuds, in VR, at home with, there's new personal soundbars, which are sort of an interesting new category for gamers, and those are incorporating spatial audio. And so that technology is basically trying to recreate as realistically as possible that listening experience.
I was struck by what you said in terms of going from mono, a single speaker, to stereo, 2 speakers. People said, well, we only have 2 ears, so why would we need more than 2 speakers?
Right.
Well, but then we went to surround, right? So we got like 5 speakers around plus a subwoofer, 7 speakers around. Dolby Atmos put speakers overhead. DTSX does the same thing. But it's still not the same. It's still sounds coming from very particular, discrete places. Whereas that's not how we experience the real world. Sounds come from any direction.
Correct. Yep. And the other thing, too, is that the characteristics of sounds at different distances have very different sort of sonic characteristics to them. And a lot of those systems don't really try to emulate or attempt to simulate those. Video games really, I think, was the big foray into this, because in those experiences, you are in a really immersive virtual environment. And it's very key to have the audio also feel like it's in that environment. They talk about a lot the term the uncanny valley when it comes to video games or movies where you're seeing CGI of humans and you're like, something's not quite right.
Yeah, it makes you creepy.
I sort of refer to this as basically, audio uncanny valley, where what you're seeing and what you're hearing don't really match, and it can pull you out of that experience. And and spatial audio really attempts to build a bridge over that valley, so to speak. Right.
Okay. Well, very good. Now, I must ask you. You mentioned that other companies have tried to do this, and there are other systems like it out on the market right now. For example, Sony 360 Reality Audio, DTS Virtual X, Dolby Atmos, for that matter, has a system whereby it sort of tries to recreate object-oriented audio with sounds coming from all different directions. How does THX Spatial Audio differ from those?
Sure. Yeah. And remember, there's also MPEG-H and numerous other flavors out there, right? Everybody has their own take. A lot of the technology is built on the same technology. So binaural audio, the use of an HRTF, which is the convolution filter that's attempting to recreate our physiology and how our ears hear. And then there's also the components of the virtual acoustics, early reflections, and then the late reflections and reverb from the virtual environment that you're trying to simulate. And so So a lot of them use all that same technology. They tend to differ in how you author for the end result. And one of the downsides is that many of them, you end up in an ecosystem that is very closed. It has to be licensed. You have to be on the right playback device to even hear the content that is authored inside that ecosystem. And that works in certain areas and sort of falls apart in other areas. And so I would say one of the key differentiators for THX Spatial Audio has been trying to have the highest quality audio experience. So even though the field is largely using a lot of the same technology, a lot of it comes down to the quality of the HRTF, the quality of the early reflections and how you process those and late reflections. And then the other big one is trying to create a technology that is platform agnostic, where it does not matter if you're listening to YouTube or Bandcamp or SoundCloud or Spotify. You basically just need headphones. And again, those can be any headphones. They can be Bluetooth headphones, wired headphones, low latency, Wi-Fi headphones. And that's where you can get the spatial audio experience. So it's a little bit more of an agnostic platform for all.
Is THX licensing the technology to different companies?
We don't need a codec, so there's no decompressor required to listen. It's just a binaural recording. It's just that our approach to creating the realism, and the quality of those recordings is where our focus has been in.
If I could jump in, there's sort of two ways, right? There's the embedding spatial audio within a stereo file, which becomes a universal experience. And then there's a post-processing solution where you take whatever the inputs are, or the outputs, I should say, multi-channel, stereo, et cetera. And then after that audio is generated, it then goes through a second layer where it's then processed, applied an algorithm that gives you the spatial through this HRTF and whatnot, and then it binauralizes it. But that way you can have a system that delivers, say, 7.1, and the system is agnostic. It just gives you the 8 channels. And then once those 8 channels are created in real time, essentially with no latency, you can then take those and simulate that realism by baking it into a scene that then gets pushed to your headphones in real time. So there's more than one way to access it. You
actually anticipated my next question, so thank you for that. Which is, and what you just said, let me summarize, you can either bake the spatial audio effect into a mix, in which case you just play it back on any set of headphones or speakers. We're going to talk about speakers a little bit later, and get that effect. Or you can just play a normal stereo or a 5.1 recording, and it goes through an algorithm running in software or in a little device or something, and gives you the same effect with any content that hasn't already been spatialized with the with this algorithm, right? Okay, so you can go either way, which is great.
Yeah. And depending on the device and the content and the playback system, we have, you can embed it and do it in real time. You can bake it into the audio itself, or you can do this post rendering. And that's one thing we didn't mention is that through plugins, like we have these game audio plugins that allows you to do THX Spatial Audio right inside of Unity or Wise or these video game engines that run in real time. And so like when you move the joystick around in your video game and are moving your character's head around, that's informing the spatial audio rendering in real time, and the same for something like VR experience.
The fact that you have very little latency is very interesting to me. I mean, this is a lot of computation going on, and you're getting. I believe you specified a latency and less than 1 millisecond.
It can be, yeah.
Can be. That's really amazing. Well, I'd like to turn our attention to headphones and earbuds in particular, and how this works here. Kasson, you mentioned HRTF, which stands for Head Related Transfer Function, which is a mathematical description of how sound reaches each of our ears and is affected by the fact that we have a head and a torso and the sound has to go around it. We've got a couple of graphics here to sort of illustrate this, and I'd appreciate it if you'd sort of explain a little bit about what we're doing here.
Sure. What you're seeing there is sort of an angular description of the convolution filters that are being applied depending on your head position and the source position of the audio that you're listening to. So in the real world, usually sound sources are moving and our head is moving. So you have both of those things moving in real time. Like when you and I are talking, it's a virtual right now, but you know, if we were in the same room, we might be moving around. Even just the act of sitting here, you can see that we're moving our head in these sort of like micro movements. And that
maybe not even so micro.
Say it again.
Not even so micro.
Right. Not even so micro. Yeah, exactly. And those are really what's needed to get a good spatial audio experiences, because your ears, the distance between them, and as you mentioned, your physiology is looking at the level and the time differences. And then with the HRTF.
And looking also at the frequency response, which changes greatly depending on where it's coming from. As you can see in this drawing, you know, a sound coming from to the right ear from the right has a very different spectrum than one that's coming from the front, or one that's coming from 45 degrees. Right.
And so the HRTF is basically a 360 dome of these convolution filters. And the more filters you have, the more you can naturally move between them. The fewer you have to essentially interpolate between them. And that can cause problems with the fewer of those, you know, the fewer you have, the more problems you might have. So these HRTF data sets try to really accurately have a lot of degrees around the 360 degree dome around your head.
Now, Sony, I hate to bring up competitors, but I'm going to in this case, actually has a system with their 360 reality audio where you take a phone and you take a picture of your ear and it generates an HRTF based upon your ear. Yes. So does THX Spatial Audio offer some sort of individualized HRTF, or is it a generalized one that's applied to everybody?
In most of our solutions, it's generalized. In the game audio plugins, we do offer what's called a PHRTF, or personalized HRTF solution. And what we have found, and this is backed up by a lot of studies that are either done at the scientific level, corporate level, or in the academic level, is that humans are actually very adaptive, right? Our eyes in particular, right? We don't see the world at like, you know, millions of frames per second, for instance. And we don't listen, where we have limits to our listening. We can't really hear below, you know, 20 to 30 hertz. And we, you know, most humans can't really realistically hear above 17,000, you know, up to 20,000. And there are timbral differences above that. And so we have found that basically a generalized HRTF, as long as you select the right one, can really work for a large part of the population. And within a few minutes, you can start to adapt to that. And so there's been a lot of sort of controversy and debate around personalized HRTF. Is it better? Is it worse? You can, if you go online, you see endless debates on this topic. And a lot of companies got really interested in it. And then many have sort of backed away because we're very adaptive to generalized ones. And so if you have a good one that provides both the combination of the out of your head, a nice localization, as well as not being too colored, you can have a really good spatial audio experience.
Got it.
It's also not a dramatic improvement. It's a subtle improvement. And people that
with the individualized one, you mean?
Yeah, I mean, people that will go through the process of trying to capture that, you know, head information and submit it, and then get something that's returned back that then overwrites whatever the general one is. They expect, you know, something that really gives them a giant change in the sound stage from what they were used to. And in general, at best, you get a subtle change. At worst, in some cases, you actually prefer it less than the general. And there's, you know, a lot of different potential reasons behind that. But frankly, one of them is just simply familiarity. Right. So you get used to something in the way it sounds and you change it, even though it may arguably be from a measurement perspective better, but from your own personal experience, you've grown used to something, and that change may not give you the improvement that the product was promising. So I think there's still a lot of work to be done and a lot of science that needs to be done to really harden a personalized product like that, which isn't to take anything away from it, because there is real value behind it. But again, the value prop is somewhat diminished compared to some other improvements that can make much more radical differences to the listening environment.
Sure. Okay, I can accept that. Kasson, you mentioned convolution filters, and I'd love for you to spend a moment talking about that. That sounds like a kind of a technical, scary term. It's related to HRTF. What does it mean?
It's basically to capture and create an HRTF data set. There are a few ways you can do it, but usually the understood way is that you need to put a human in an anechoic chamber. You need to get them so their head is at a fixed position. And then you basically rotate. You have a speaker in every single one of those 360 degrees, and it plays a sine wave sweep, and you have little microphones inside your ears that are sort of pushed really far in. And then basically each speaker just runs a sine wave through at a sweep from 20 hertz to 20 kilohertz. And then what you can do is you can look at that frequency response of that one position recorded by both ears and basically have two of these convolution filters, HRIRs, that are then used to do the HRTF processing in real time. And if you look at it, and if you go back to the graphic or show that graphic, right, it's just a frequency response like you would see if you would do a measurement of headphones, right? It's 20 hertz at the bottom and 20 kilohertz up at the top. And you can see the dips and the peaks. And those are really the how your pinna is affecting it, the shape of your ear canal, and your head and torso as sound waves hit and scatter and enter your ear canal.
And if, in fact, we just saw that graphic, the next one actually that I wanted to show, which is the convolution filter. Tell us what we're looking at in this graphic.
Right. In this case, what you're looking at is a way to compensate for filters. And so one of the ways you can use filters is to look at dips and peaks and actually try to do the inverse and smooth them out. So in some cases with a lot of HRTFs, you'll get the sort of raw filters, and you may actually want to go in and clean up some of the extreme dips and peaks to smooth it out. And really what you're changing there is sort of you're compensating between how localized and out of your head and diegetic does the sound feel versus how colored is it. And so a lot of people, when they listen to spatial audio, sort of as newbies or, general people coming to the technology, they react really strongly to it sounding very colored. And especially, as you know, all audio content is different, right? I mean, vocal driven music is so different than instrumental music. And so you may have a particular HRTF that really emphasizes or de-emphasizes key frequencies in the human voice and can start to color it in odd ways. And so it's another reason why I believe a high quality generalized HRTF can work better, because you can select one that tries to work for as much different kind of audio content, ranging from speech and podcasts to music to movies and games.
So Jason, not only does THX Spatial Audio work in headphones, but it's also designed to work with speakers. And I'd love to hear a little bit about how that works, because of course headphones are isolated. You can isolate the left and the right perfectly, and ne'er the twain shall meet. But with speakers, they're in a room, and the sound from each one is going to reach both your ears.
Correct.
So how do you deal with that?
Well, so THX Spatial Audio is sort of a catch-all term. It doesn't necessarily refer to one technology that's applied across both mediums. So in the headphone domain, as Kasson's described, it's really more of an HRTF and convolution filter technology. In the speaker domain, it's based on a principle called crosstalk cancellation. So as you correctly noted, if you have two speakers in front of you, a pair of stereo speakers, the speaker on the left will reach your left ear a fraction of a second before it reaches your right ear, and vice versa. Algorithmically, you can more or less remove that cross and then get a pure audio signal from your left ear from the left speaker to your left ear, and from the right speaker to your right ear, and algorithmically cancel that cross, hence the expression crosstalk cancellation. And this is actually a very old technology. It's been around for quite some time. One of the effects, or one of the sort of like things that happens when you engage or you listen in that, is the audio has the ability to either sound as if it's emitting right from next to your ears, so it can create kind of a virtual headphone type profile, or it can create a much wider sound stage from where the position of the speakers are. So if you think of a sound bar, which is an easier metaphor because the left and right speakers are permanently fixed in a position, you can create a profile where the sound sounds like it's coming from a much, much wider environment than the position of the left and right, to the point where it can fill a room, depending upon the room and the reflections, where it does give you the sense that sound is coming behind you, above you, but certainly a much wider space than what you would expect from a relatively small sound bar, such as a game gaming soundbar. And so applying crosstalk cancellation plus some additional enhancements that, we've developed some and patented a few. Other companies have their own version of delivering a speaker technology. Some people use something like an align array with beamforming. There's all different ways of teasing the sound from a pair of speakers or from multiple drivers to give you the sense of immersion, to give you the illusion of surround without actually needing speakers placed to your left and right and behind you. And in many cases, you don't even necessarily need a center channel. You can create a virtual center, all by teasing the audio algorithmically, and the impact and the effect of that gives you a very rewarding, immersive, exciting experience that most people, when they hear it the first time, just go, wow.
Well, I've heard it before, and you're right. It is not a new technology per se, and I have heard it, and I have heard very effective examples of it. So I'm convinced that this is certainly possible. You have a nice little graphic of virtual surround, I think, in a home theater system. It'd be number 4,
There you go.
where yeah, you've got, I guess, a sound bar probably in this graphic, but the person watching the program seems to hear sounds coming from all around.
Yeah, I mean, obviously, marketing graphics don't always give you the exact indication of what the experience is. It's really more of a semicircle, or maybe sort of like a semicircle with a little bit of the audio below. You don't really get audio coming, say, from the floor or something.
Yeah,
but,
right.
From a marketing perspective, it helps to sort of illustrate that you kind of have like a ball of sound that you're surrounded in, which is not the way you would expect a pair of speakers to sound.
Right.
And yet when you do hear it, it gives you a much richer, much more immersive, much more authentic experience because of the way that the software has been deployed within the hardware.
Right. Now, in addition to sound bars and speakers, you're also focusing on computers, and in particular laptops, which often have pretty lousy sound. Tiny little speakers in tiny little enclosures. How are you addressing that particular market?
Carefully. We obviously come from a background of quality, and so we work very closely with our partners to make sure they select the best possible drivers. We put a lot of technology into a very small space and try to maximize not only the audio quality, but also the immersion from what is a relatively small speaker. But if you've heard good sound from a laptop, then someone's really done a great job of not only creating perhaps a surround sound environment or a crosstalk environment from the speakers, but a lot of other technologies like pseudo bass. You really don't get a large sub. So how do you get that boom when you're listening to laptops? There are ways of, algorithmically creating a virtual sub. I've seen laptops where they have like a little teeny tiny sub plugged in the back that's supposed to simulate the experience of a sub. Anything you can do to it adds a lot. There's compression technologies that can also enhance the audio quality. And so, these days I'm seeing a lot of startups coming to us with, little doodads they've designed to improve, loudspeakers. But I think the lion's share of the development that I've seen has really been in how do you maximize audio quality from a relatively small speaker. And it's really a combination of two things. It's good speaker design. You got to have sealed boxes. You want to have some batting in there. You want to make sure they're placed appropriately. If you're, downward firing, you want to make sure that the angle's correct. So the reflection, gives you an authentic sound stage. And of course, if you have multiple speakers, you have different ways of, canceling some of the vibrations and some of the other stuff to give you a more immersive experience. So I think, in addition to the design and the implementation of the hardware, then you layer on top of that the tuning that we can deliver both for a stereo experience and a spatial experience. And I'd say we've been very successful in doing that, in that many of the laptops that we've developed do get compared favorably to the audio quality of a MacBook. As we all know, Apple does a lot of, R&D. They have an incredibly, large and very qualified team. And generally, Apple's audio is held up as the benchmark for which all other laptops aspire to sound like.
Sure.
We've been well rewarded in the media for helping some of our partners create laptop audio experiences that rival that of the MacBook. And we take a great deal of pride when we read that in reviews.
Cool. Very good. Now, of course, a lot of laptop users use headphones.
Correct.
And we have a couple other marketing graphics I just wanted to show that are kind of cool. 5 and 6, again, showing somebody working on a laptop with headphones and having a spherical thing. This one in particular, this second graphic, what is that showing? There's these yellow specific little areas. What are they?
It's really sort of indicating what Kasson was talking about. It's sort of a visual of how an HRTF, which is essentially, audio impulses on a curve, when wearing headphones. So if you're wearing a pair of headphones and the processing is done on the PC, it can be a gaming headset, it can be TWS, it can be just a standard, pair of cans. Again, the HRTF helps extrude the audio, and it gives you, depending upon how good your rendering engine is, a high quality sphere of audio. And again, depending upon the sound, of course, we're talking a lot about the hardware and the technology. There's no way to avoid talking about the content as well, right? Content that has like hard panning or a lot of reverb will spatialize a lot better than, say, a single center channel speech channel, or perhaps electronic music that doesn't usually take, a lot of dynamic range into account. It's very sort of, right up in your face. Mm-hmm. So depending upon the quality of the content will really determine how far out of your head the, assuming you have a well authored piece of content, a good, hardware, and a good, algorithm, you can get a experience that does replicate kind of audio wise what you're seeing visually in that, where you have constant movement of objects and sounds around your head, in some sort of a 360-degree plane, or in some cases simply on the azimuth plane, depending upon what the content is and what the user's expectations are.
Mm-hmm. One last question before we end part 1 here. We're going to keep talking, but that's going to be in the next episode. But for now, when we were talking about headphones, I forgot to ask about head tracking. This is kind of an important thing in spatial audio generally, where as you move your head around, ideally, you want the source, the apparent or virtual source of the sound that you're listening to stay where it is, not to move with your head. Do you guys deal with that?
We do. And it's something that I think you're going to be seeing a lot more in the coming year. Obviously, spatial audio is an evolving technology. I don't think by any stretch of the imagination we sort of reached peak spatial audio. Ourselves and other companies are continuing to innovate new solutions to try to give you more realism, working with content creators to output more audio in different formats. And I think where things are gravitating to now is, now that we've got, I think, a great HRTF-based spatial audio solution, the next is to maintain the position of those virtual emitters so it replicates reality even further. Whereas you sort of correctly noted, when you don't have head tracking and you turn your head, the entire scene moves with you, which, you're used to it, so you don't really think about it. It's only once you first experience and you have the scene and your head moves and the emitters stay where they are that it's like that big aha moment. Like the first time you put on a pair of noise canceling headphones and you turn on noise canceling, it's an immediate and impactful change. We find the same thing is true for head tracking. You can have a great spatial audio experience, but if you don't have head tracking, you're really only getting a portion of what's possible. Adding in head tracking, you really get an extra dimension that accounts for movement in a way that the audio doesn't move, but your head does, and that furthers the realism of the experience. Much like much like a flight on an airplane, you don't want to remember it. You just want to think I flew. So you don't want to remember that you like, oh yeah, I had my audio moving or not moving. You just want to sort of feel like that felt real.
Right. Exactly. So that's something that is still under development. It's less far along, shall we say, than the HRTF at this point?
From our perspective, we have a lot of things in the works, under development versus, sort of currently in the sales process, perhaps the best way to put it. So we do have products we're demonstrating to potential partners that involve head tracking. So there is a mature product there. But, we continue to work on different versions of head tracking. There's head tracking that you can get via an IMU placed inside the device, the headphone, or a dongle that attaches to it. You can also achieve a type of head tracking using a built-in laptop camera or an external webcam. So each of which can give you a head tracked experience that, one married with a spatial audio engine, really gives you that extra dimension of realism.
Sounds great. Well, we've come to the end of this episode, but we're going to keep our conversation going in part 2, where we're going to talk about applications and where you can actually go hear THX Spatial Audio. So I do hope you will join us for that. Hey there, I hope you enjoyed this episode of Home Theater Geeks. If you'd like more, you need to be a member of Club TWiT, which costs only $7 a month, and that gives you full access to everything the club has to offer, including all podcasts ad-free and access to the club Discord. Or you can subscribe to Home Theater Geeks by itself for $2.99 a month. You can also get the ad-free audio version for $2.99 a month on Apple Podcasts. New episodes drop every Thursday via Club TWiT and Apple Podcasts. With full club membership, you can even watch us record the show live. Just keep an eye on the events tab in the club Discord for the schedule. I hope you'll join me for a weekly dose of home theater geekitude. Until then, geek out.